Good morning. Welcome to the session of instrumentation engineering. And today the discussion topic is feed forward and the ratio control. And the prerequisite for this particular topic to understand is sensor and transducer, industrial instrumentation and control theory. So before we proceed, we will try to go through a very well-known control loop strategy which we have already discussed in different areas of the discussion. That is nothing but the feedback control. So from the general control loop block diagram, if we just try to visualize this particular loop diagram, so we are able to see that the different loops, if we talk about, then the process will be the significant part of the discussion, and the process will be controlled by the controller using the final control element, and the process parameter will be measured by the measuring instrument like sensor or transmitter. But one of the crucial part of the discussion in the general control loop block diagram is if the process is consisting with some disturbance. In the practical circumstances, it is very evidently proved that the disturbance is incorporated in many segments in the process. So this disturbance cannot be eliminated before it happens to the process. So if we talk about this general control loop block diagram, so whenever the disturbance is already incorporated in the process, then only your measuring instrument, sensor or transmitter can acknowledge this particular disturbance, and then the corrective action or the corrective measurement can be taken from the controller and the final control element. So that's why this particular general control loop block diagram or the control loop strategy is mainly concerned with the compensatory control. So we today in our discussion, the major concern is the disturbance rejection before it happens to the process. So that's why we will proceed towards a new strategy which is nothing but known as a feed forward strategy or feed forward control that will try to be discussed. So if we talk about the feedback control loops that cannot achieve or cannot be never achieved the perfect control because of the compensatory nature, which already we have discussed in the first slide. So whenever the disturbance will be incorporated, the disturbance will be acknowledged by the sensor, and then the corrective actions will be taken by the controller. So that is nothing but the strategy which we can be called for the feedback control, that it can be compensate the disturbance. It cannot eliminate or cannot be anticipate the particular incorporation of the disturbance, and unable to keep the output of the process continuously at the desired set point value in presence of load or set point changes. So another point of the discussion why we should go for another strategy or another control is that particularly the feedback control loop is unable to go for the desired set point change in the value or the load or the disturbance if it will be changed. So in such cases, your conventional feedback control cannot be achieve a desired output. A feedback controller reacts only after it detects a deviation in the value of the output from the desired set point. So as already I have mentioned that whenever the feedback control reacts only after the particular disturbance or load has been incorporated into your process. So a feed forward control strategy at the configuration is mainly concerned about the disturbance or the load rejection, which directly can be take the information about the disturbance or the load, and immediately before it happens to the process, the particular actions can be taken by this arrangement or the control strategy which is known as the feed forward control strategy. So here we have taken a one of the example of CSTR, which is the continuously treated tank reactor. So here you are able to see that the input or the feed, if we talk about, that is Fi and Ti, that is nothing but the flow input and the temperature input, and there is a tank which is nothing but the continuously treated tank reactor, and mainly we try to maintain the flow and the temperature at the output, and the steam will be given to heat up this particular reactor to make the reaction, make the temperature of the particular chemical at their desired flow and the temperature level. So in such particular case of the operation, how this particular feed forward and the feedback control strategy can be incorporated, that we'll try to be understand from the next slides. So if we talk about the conventional feedback loop, so obviously the major concern of this particular process is to maintain the temperature in the CSTR. So that's why you are able to see that we have incorporated a thermocouple to measure the temperature from this CSTR and try to give a set point through which the error will be calculated. and according to the error, the controller will go through the corresponding uh, control action generation, and this control action will be given to the final control element through which the steam will be incorporated into the tank. So whenever, if we talk about the disturbance can be incorporated through the feed or the input, which is nothing but the flow and the temperature, or from other areas. So whenever this particular disturbance will be incorporated into the process, then only the thermocouple can be understood that yes, the temperature has been increased, and then the set point or the error will be calculated, and then the controller will take the corresponding control action, and the final control element will take the opportunity to increase or decrease the steam flow in the particular tank. So we are not able to eliminate or not able to anticipate that when the or where from the disturbance or the load has been incorporated. It is only being counted whenever the load or the disturbance has already been incorporated into the process. So this is a major drawback, we can say, for the feedback loop, which is nothing but we can eliminate using this conventional loop or the feedback control strategy. So now if we just try to proceed for the feed forward control strategy, so here you can see that we have not taken any type of information from the process itself. So because we need to maintain the temperature of the CSTR of this tank, so here we have not using any thermocouple or any type of other measuring instruments. We are focusing that if some disturbance has been happened, that is coming from the feed itself, and the temperature Ti, which is the inlet temperature of the feed, that can be a issue for the case of the disturbance. So that's why here you can see we have used a thermocouple to measure the temperature of the feed itself, not the temperature of the particular process, which is the tank. So here the thermocouple will measure the temperature, and using the thermocouple temperature we are trying to measure the error itself, and after that using the thermocouple temperature, if the maintaining temperature is increased or decreased, so in that cases controller will take the corresponding action whenever it will just try to come to the process in the tank. So it is anticipatory in nature, we can say. It is not compensatory in nature, because we are try to understand that whatever the temperature change is there before it happens to the process. So that's why this feedback control strategy is known as anticipatory in nature, not compensatory in nature, which already we have discussed for the closed loop control. So that is a main point of discussion, that the disturbance whenever it will be incorporated into the process, then the compensation can be done by the feedback control, whereas the anticipation or the predictions can be done by the feed forward control if you have knowledge about that particular process. And whenever we are talking about the disturbance, that means we are majorly concerning about the disturbance which is coming from one point or one input or the output from the process. So this is basically the strategy itself, we can call it, for the feed forward control. But one of the drawback, if we try to understand that whatever the disturbance we try to eliminate using this feed forward control, but we don't have any knowledge about the process, so it is a major drawback or the major point of concern, we can say, for the feed forward control, because there is a chance that the disturbance can be incorporated in the output itself or from the other sides of the process or other inputs. So here we can say, we can take a opportunity to discuss that maybe the disturbance can be happened into the stream flow line also. We are only incorporating or only acknowledging the temperature changes in the feed or the input, but we are not concerned about the steam flow over here. So here also a chance that the disturbance can incorporate it into the process. So that's why another point of the discussion is, you cannot acknowledge all the disturbances using the feed forward control for most of the cases in the practical circumstances. And another point of the discussion is, you are not getting any information about the process itself by the feed forward control. So now the basic structures of the block diagrams is given in this particular discussion. So here itself from the process we are evidently proved that the feed forward control, if we talk about the first diagram, so you are able to see we have not taking any type of information from the process. We are only concerned about the disturbance. We are trying to measure the disturbance. We try to make the control action using the particular change of the disturbance and try to incorporate it in the controller through the final control element and try to acknowledge by the process before it happens, or we try to anticipate it. But whereas for the case of the feedback control, here you are able to see that all the information, maybe if we approximated 10 of the disturbances incorporated in my process. So whenever I will just try to take the output from the process, so the incorporation of the 10 disturbance will already be acknowledged into the process. And whenever I will take the output, so in that time, it is very clearly we have able to visualize that all the disturbance can be acknowledged by the sensor or the value or the set point which we have taken care. So that particular information will be given to the controller, and correspondingly the control actions will be generated. So obviously the drawback is there for the feedback control, but one of the major point of the concern is that maybe we are compensatory in nature for the feedback, but all the disturbance can be acknowledged. But whereas for the feed forward control, if we talk about, only few of the disturbances can be acknowledged as per your expertise or as per your idea, but you cannot predict that all the disturbance can be acknowledged by the feed forward control. And another major point is we don't have any type of idea about the process. So that's why for the case of the feed forward control, we need to approximate the particular transfer function of this process, which is definitely cannot be predicted the actual model or the actual plan. So that is another point of the discussion for the feed forward control. So drawback of the feedback control, if we talk about, the control action starts immediately for set point change, but not for the change in the load disturbances. So as I already mentioned that the control action needs to be generated whenever the acknowledgement has been given by the feedback control. So whenever the disturbance has been incorporated into your process, then only your sensor can be acknowledged about the disturbance, and then the corrective actions will be taken. Regulation ineffectively for the process with large time constant delay to load disturbance for frequent change in disturbances. So it is another point of the discussion for the delay dominated processes or the lag dominated processes. So here one of the point of the discussion is whenever the process will be consisting with some delay or the time delay or the process delay or the transportation delay. So in such cases there will be a huge chance of disturbance that has been incorporated that is not been acknowledged immediately, that is also go through a time scale which is the time delay or the delay which we have concern about. And obviously the diverging situation may occur by using a single control strategy. So that is a point or the drawbacks we can say for the feedback control. Whereas some of the facts of the feed forward control, if we talk about, it measures the disturbance directly and then it anticipates the effect that it will have on the process output. So as I already mentioned that we are majorly concerning about the disturbance for the feed forward control. So in such cases, initially what we'll try to do is we try to know about the disturbance or the change of disturbance or the change of parameter which can acknowledge the disturbance into the process. So whenever we are getting some other values or the different values from the set value of the input or the output parameters, so we are acknowledging it as a disturbance and try to anticipate or try to make the respective control action generated in the controller before it happens to the process. Subsequently, it changes the manipulated variable by such an amount as to eliminate completely the impact of the disturbance on the output process. So as I already mentioned that before it happens to the process, so the manipulated variables value can be changing or the amount of the manipulated value can be changed, and we can make the information about the particular disturbance, so the corrective actions can be taken. It is clear that the feedback acts after the fact in a compensatory manner, where already I have discussed about the compensatory nature of the feedback control. So without incorporating the disturbance into the process, you are unable to get any information about the disturbance for the case of the feedback control. But whereas for the feed forward control, it acts beforehand. That means it is acts nothing but the anticipatory in nature, not the compensatory in nature. So whenever we talk about the feed forward control, we are majorly concerning about the disturbance, and beforehand we'll try to make the corresponding control action generated by the controller and try to anticipate the disturbance before it happens to the process. As a result, the speed and performance of the overall system improves in the feed forward control strategy, and together with the help of the feedback action is employed. So mainly if we talk about the industry, both the feedback and feed forward will play the vital role whenever they will be acknowledging in a process simultaneously. Because one of the drawback, if we try to say, for the feedback control is we don't have the potential to restrict the disturbance before it happens to the process. So that's why that can be the drawback of the feedback control. But the most important or the beneficiary part of the feedback control is you are acknowledging all the disturbances at the output side or using the transmitter or the sensor. But whereas for the feed forward control, we are acknowledging the disturbance before it happens to the process. But for the feed forward control, we are not having any information about the process. So if we just try to club the feed forward and the feedback control, then the closed loop response, which we can be says as desired closed loop response, can be achieved for the servo as well as the regulatory control. Now, this is the particularly block diagram which we are talking about, in which the process is consisting with the feedback as well as the feed forward control. So here you are able to see that the process is consisting with the feedback and the feed forward control, in which particularly the disturbance which we are talking about, the disturbance is acknowledged by the feed forward control, and corresponding or the respective control actions has been generated, and it will try to incorporate it before it happens to the process. Whereas using the feedback control, we are able to see that the feedback controller will acknowledge the information about the process, that how many how many disturbance has been acknowledged into the process. So the entire information about the process can be acknowledged by the feedback control, and corresponding control actions has been generated. So using this both appointment of the feedback and the feed forward control, we are able to see that the process can be controlled desirably for the servo as well as the regulatory control. So this is the best option, that whenever we want to use the feed forward, it needs to be used with the feedback control, that the entire desired, which is nothing but the servo tracking as well as the load disturbance rejection, that is nothing but simultaneously called as a desired closed loop response, can be achieved. So if you talk about the remarks, so the feed forward control ideally does not get any feedback from the process output. Already I have mentioned that the feed forward is only concerned about the disturbance. It is not at all concerned about the particular process output. So maybe you are acknowledging few of the disturbance, but it cannot be ensured that all the disturbance can be acknowledged by the feed forward control. So that's why the point has been given. Hence, in solely work on the merit of the model. So whenever, if you want to use the feed forward control in a single without using the feedback control loop, then it needs to be used the model transfer function of the particular process. It needs to be defined in the form of a numerator and denominator, and it is nothing but the model which we have approximated from the actual process. The better a model representation or the behavior of a process, the better would be the performance of the feed forward control design on the basis of that model. So because we are only predicting the particular transfer function of the process, so that needs to be very careful whenever we are approaching towards only the feed forward control, because as per the performance of the feed forward control is mainly depending on this model approximation. If the model approximation is closely towards the actual process, then the output will be good enough. But whereas if the approximation of the model is not at all very close to the actual process, then there will be a huge chance of offset in the output for the case of the set point tracking as well as the disturbance rejection. Perfect control necessitates perfect knowledge of the process and the disturbance model, and this is particularly impossible. So as I already mentioned, that you cannot predict a particular process in an actual scenario using a transfer function of numerator and denominator. So it is nothing but impossible to use the feed forward control and get a perfect output for the case of the closed loop response, because the perfect control necessitates the perfect knowledge about the process, and in the actual process, many of the times the process parameters, that means the open loop gain, the time constant, the date time, they are changing simultaneously with the time scale. So it is very impossible to say that using only the feed forward control we can get the actual output and the better output from the feedback control, because the disturbance can be acknowledged, but because we doesn't have the idea about the models or the process, so that is a point of concern. This is in turn in the main drawback of the feed forward control. So because we doesn't have any idea about the model, this particular the idea about the process, so this particular point can be taken care as a drawback of the feed forward control, in which we don't have any idea about the actual process. We are only predicting the process in terms of a transfer function. The feed-forward control configuration can be developed for more than one disturbance in multi-controller configuration. So as I already mentioned, a process cannot be only consisting with a single disturbance. There are many of the disturbance can be acknowledged at the time of actual processes. So the point is, you needs to be acknowledge all the disturbances, and it is nearly go through the different disturbance segments, and multi-control configuration will be required, and any controller in that configuration would act accordingly to the disturbance for which it will be designed. So if we talk about, already we have talked about the disturbance incorporated in the feed or the input side, so maybe there is a concern that the disturbance can be incorporated at the output side also. So that is the point of concern, that multiple number of disturbance can be incorporated in a process in a single time, so multiple controller configuration needs to be required. So that is a point of concern for the case of the feed forward control. External characteristics of the feed forward loop are same as that of a feedback loop. So external characteristics, obviously the feed forward and the feedback loops are mostly the same, which we have talked about. The primary measurement, basically the disturbance in case of the feed forward control and process output in case of the feedback control, is compared to the set point, and the results of the comparison is used as a actuating signal of the controller. So here the information for the case of the feed forward control has been taken from the disturbance itself, and that will be compared with the particular set point value of the disturbance, that whatever the input or whatever the value of the disturbance needs to be maintained. Otherwise, if there is any deviation, then the corresponding control action will be generated. And for the feedback control, we are taking the information about the output of the process, and that particular output of the process will be acknowledged by the set point value, and the corresponding error will be generated, and the corresponding respective control action will be generated using the final control element. So the strategy will be same, but the different area of the concern is there. Except the controller, all the other hardware elements of the feed forward control configuration, such as sensor, transducer, transmitter, valves, are same as that of an equivalent feedback controller configuration, because that is nothing but the different ideas of the feedback and the feed forward, but it is nothing but the closed loop for both the cases. So obviously the sensor, the transducer, the transmitter, the valves, all the things will be required for such cases. Feed forward control cannot be expressed in the feedback form such as P, PI or PID controller, and it is very evidently understood that the P, PI, PID control strategy, the proportional, integral and the derivative control strategy, is mostly designed to control the entire process, not the disturbance itself. So that's why this is not very sufficiently used, the P, PI or PID controller for the feed forward control, and it is regarded as a special purpose computing machine for the eliminating of disturbances for such cases. So that's all for the first part of the discussion. We will discuss about the feedback and the ratio, feed forward and the ratio control in the next part of our discussion. Thank you.